instruments. So your final exams is in May. So you have optical instruments.
We completed simple microscope.
You have completed both the cases of simple microscope. One is when the object is at the least distance, and another is when the object is at infinity. See, when the final
Yeah.
image is at least distance and the final image is at infinity. We completed both
Yeah,
the
we have
cases.
completed both. Both, sir.
Completed both. We did any numerical? No, I don't think. We have not
No,
done any
sir.
numerical. No numerical. So let's do few numericals on simple microscope. Few numericals on simple microscope. So if you have a simple microscope and you have two positions, one is the position of object at infinity, when your object is at infinity, and another is when your object is at least distance. When your object is at least distance of distinct vision. So if your object is at infinity, then the angular magnification was minus of d by f, right? This was the formula of angular magnification, minus d by f or plus d by f?
Plus.
Plus d by f. When your object is at least distance, then your angular magnification is 1 plus d by f. So we'll do numericals on these two concepts. The angular magnification of simple microscope when your object is at infinity and when your object is at least distance of distinct vision. Solve first numerical, first basic. And one more thing, in both these relations, while using both of these relations, no need to consider sign convention. In both of these relations, no need to consider sign convention. No need to consider sign convention in both these relations. So in a numerical, if the value of d is 25, then put it as 25. Don't take sign convention. If focal length is 10 centimeter, take it as 10 centimeter. No need to use sign convention in those cases. So I'm giving a simple numerical. So Froza, you remember these calculations? We were doing optical instrument. In optical instrument, we have completed simple microscope. Even in simple microscope, we did these two cases. Huh? The case one, when your object is at least distance, and case two, when your object is at infinity. So let's solve this simple numerical. Okay, solve this numerical. A converging lens a converging lens of focal length 6.25 centimeter is used as a magnifying glass. If near point of observer is 25 centimeter from eye, calculate first part. Distance of object from lens. So for this, you can simply use lens formula. Second, angular magnification. For angular magnification, you can use this relation because your final image is at 25 centimeter. Huh? That's your image distance. This is your image distance. Third, angular magnification. Angular magnification when final image is at infinity. When final image is at infinity. Okay, solve all these three parts and report your answer. Afroza, first one is straightforward. Huh? You have image distance, you have focal length, use lens formula and get the value of object distance. For angular magnification, you can directly do this 1 plus d by f. D is 25 centimeter. For the third case, you calculate d by f. Afroza, start your calculations. Answers. First part may be wrong, but I'm very sure that you won't make any mistake in second and third part. After that, D is 25, F is 6.25. Start your calculations. Just report answer of part 2 and 3. If you're having difficulty in part 1, start with 2 and 3. They are straightforward. If you can't solve, should I solve this? All three parts? Jibana. Okay, you're doing. Solve it, solve it. Okay. No. First is wrong. Okay, I will solve the first one, but you try at least second and third part. Okay. Okay, let's start with part one. Huh? Okay, your second is, I think your second part is correct. Second is, no, not even second is correct. See, for the first part. In the first part, you need distance of object from the lens, object distance. So you have focal length, which is 6.25. You have image distance, which is 25 centimeter. So the focal length is 6.25 centimeter. Your image distance is 25. Image is obtained at the same side, so it's minus d, minus of 6 point, not 6, minus of 25 centimeter. Next, you can use this lens formula. 1 by v minus 1 by u is 1 by f. You can write 1 by v minus 1 by f is 1 by u. So 1 by v is minus 25. 1 by f is minus 6.25 is equal to 1 by u now. So now you have 1 by u is minus 1 by 25 minus 1 by 6.25. This is 6 LCM is this. So 1 by u is, you can take 625 as LCM. So 25, 25, 625. So minus 25 minus 10. So your 1 by u comes out to be minus 35 by 625. When you cancel it, it's 57, 51, 52, 1, 2, 5, 5 is 25. 7 ones are 7, 7 5 is 35. So your object distance comes out to be minus 15 centimeter. This is your object distance, which is minus of 15 centimeter now. So that's the part one of the question. In the part two, you're supposed to calculate the angular magnification when your final image is at least distance. When your final image is at least distance, your angular magnification is just 1 plus d by f. D is 25. This is 6.25. So your angular magnification comes out to be, if I 6.25, 4s are 25, so it's 1 plus 4. Your angular magnification comes out to be 5. So if your final image is obtained at the least distance of distinct vision, then the magnification that your microscope will produce is 5 only. Part 3, if your final image is at infinity, then your angular magnification is d by 5. Huh? If it is d by 5, that means d is 25, d by f is 6.25, so that is 4. When your final image is at infinity, then angular magnification is 4. Just tell me, is it clear now? Okay. Okay, just note it down and tell me when you have written. Huh? We will do the next thing, which is compound microscope. Next, we will do compound microscope. Okay. The next is compound microscope. Huh? Now, simple microscope can magnify your image to a very small extent. Like it can magnify your image up to 5 times. Means if the size of the object is 1, it can magnify it up to 5 times. But if you want to magnify your object up to 100 times, then simple microscope is not sufficient. You need something else, and that is compound microscope. See, if you want to see some parts of a watch, if you have a watch, you want to see the parts of the watch, then simple microscope is sufficient. It will magnify the parts of the watch by 5 times, so you can easily see them. But if you want to see the bacteria, or if you want to see the organelles of the cell, then simple microscope will not work. You need something which have higher magnifying power. You need something which can magnify your image 1000 times. Magnifying 1000 times means if the size of the object is 1, then the size of image that this instrument will produce will be 1000. So to magnify images, you need something else, which is compound microscope. So what is compound microscope? It consists of two convex lenses, two convex lenses of short focal length and short aperture. Short focal length and short aperture. So you have two convex lenses. Both the convex lenses have short focal length and short aperture, small aperture. Aperture means size. The size is small. It can magnify up to 1000 times. It can magnify up to 1000 times. It can magnify your image up to 1000 times. 1000 times. This is your compound microscope. So the two lenses that we use in compound microscope are objective lens and eye lens. Objective lens, objective lens. Now this lens is placed close to the object to be magnified. It is positioned near the object to be magnified. To be magnified. So this is simply placed near the object which you want to magnify. Positions near the object to be magnified. It is a convex lens of short focal length and short aperture. Convex lens of very short focal length and short aperture. After objective lens, the next lens that you have is known as eye lens. Eye lens. It is positioned near the eye. It is positioned near the eye to view image. Near the eye to view image. It is again a convex lens, but its focal length is comparative larger than that of objective lens. It is convex lens of comparative large focal length, large aperture and focal length than objective. So these are the two types of lenses that we use in compound microscope. One is objective, another is eye lens. Then here also we will calculate the magnifying power. To calculate magnifying power, we will consider two cases. Case one, when your final image is at infinity, and another case when your final image is at least distance of distinction. Just note it down, then we'll start with the first case. And tell me when you have written up. If you know one case, then another is straightforward. Just tell me when you have written. I will change the slide. Okay. So just like simple microscope, we have two cases. Case one, when final image is at least distance. When final image is at least distance of distinct vision. Final image is at least distance of distinct vision. Case 1, when your final image is at least distance of distinct vision. Least distance of distinct vision means your final image is at 25 centimeter from that. Let's first make the ray diagram. So this is your first lens. This is your first lens, which is known as objective lens. First lens, which is known as objective. This is the focus of the objective. Beyond the focus, I place this object AB. So your object AB is placed beyond the focus of the objective. Your aim is to magnify this object. So this objective lens will first make an image of this object. So this is one ray which is passing through the optical center. It will pass straight. Then you have another ray. After refraction, these rays will meet over here. This is ray which is parallel principal axis. After refraction, this will pass through focus. And the ray which is passing through the optical center will pass straight. Both the rays will meet at some point, and this point is your image, A prime, B prime. This is your image for objective. That's your first image. This is image for objective lens. Now, next comes your eye lens. Eye lens is larger than your objective. It's comparative large than your objective. This is your eye lens. This is eye lens. For eye lens, this A prime, B prime will act as an object. So the same thing, A prime, B prime is an image for the objective lens, but for eye lens, this is for objective lens. But for eye lens, I'm using red color for eye lens. For eye lens, this will act as an image, not image, sorry. This is object for eye lens. Same image, A prime, B prime. Image for objective lens, but object for eye lens. Now, this is the optical center of the eye lens. So now these rays will pass through this eye lens. So one will pass through the optical center. The ray which is passing through the optical center will go straight. It will not deviate anywhere. It will go straight. You can produce it in the backward direction. This you can produce it here in the backward direction. Another ray. This is another ray. After refraction, this just a second. After refraction, yes. After refraction, these two rays will diverge. I'm using some manipulations. Just give me 1 second. I will explain what I'm doing. These are dotted. Basically, if you want to draw these ray diagrams without rubbing, without erasing, then you should know some manipulations. Otherwise, you keep on erasing it, you will draw it, you will erase it, and that will waste your time. So see, this is your A prime B prime, which is the object for islands. One ray is passing through the optical center, it's going straight without any deflection. Another ray, which you incident here, it diverges. These two rays just diverge. When you produce them in the backward direction, so these rays are not meeting in the forward direction, means the image cannot be a real image. Rays are not meeting, image cannot be real. But if you produce them in the backward direction, then they will appear to meet at a point. They will appear to meet at a point, and this point is your final image. This is your final image. And this image is not real, it's a virtual image. Huh? Rays are not actually meeting, you are producing them. This is final image. And this final image, you can name it as A double prime, B double prime. And this final image is, this is image for islands. This is the final image. The image that you view from a compound microscope is this image. This is the final image. So this is AB. What is AB? It's object for objective lens. This is object for objective lens. Then you have A prime, B prime. What is A prime, B prime? It's image for the objective lens. And this A prime, B prime is object for the eye lens. And this A double prime, B double prime is the image for the eye. This is object of the eye lens and this is image of the eye lens. Now let's mark some distances. This distance is U naught. Object distance for objective lens. This distance is F naught. We call this distance as V naught, image distance for objective lens, V naught. We call this distance as UE, object distance for eye lens. And we call this distance, this whole, this to this distance, this whole distance. I should use different color. This distance, this whole. This is VE, image distance for eye lens. I call this as VE, which is equal to D, because we are claiming that your final image is at these distance of distribution. So the final image is virtual, it's not a real image. One more thing, these two rays just diverge. So somewhere here is your eye. Your eye is placed very, very close to the lens. Because when these rays enters your eye, then only you can see them. You can see these images only if they're entering your eye. So this is your eye. When you produce them, they appear to meet at a point, and this is your final image, basically. So this is your object, and this is your image when you're viewing it through the eye lens. There's one more thing. Just to know how much you have magnified this image, you should first see this image with the naked eye. Then only you can realize how much magnification is done. Right? If you want to compare how much magnification this compound microscope have done to your object, you will first view your object from the naked eye. So whatever I'm drawing, it's for naked eye now. Instead of lens, I put an eye. This is eye. This is your object, AB. I place this object at a distance of D from the eye. This distance is D. I place this object at a distance D from the eye. This angle is theta, or I call this as alpha. This is the angle which is subtended by object. This is your object which you are viewing through your naked eye. That's your object, and this is your eye. It doesn't look like eye, but this is eye. And this is your final image, which you are viewing through the compound microscope. This final image is subtending some angle beta on the eyelids. So your magnification is basically the ratio of this alpha and beta. This alpha have all informations about the size of the object, and this beta have all informations about the size of the image. So once you have alpha and beta, you can compare the size. This ray diagram is very crucial. Whatever we derive, we will derive using this ray diagram. Just tell me, is it clear, this whole ray diagram? Is this ray diagram clear, Giovanna, Froza? Okay, just note it down and tell me when you have written. Huh? Just note it down. We will start calculation only after completing this ray diagram. Giovanna, Froza, just tell me if you have written. Okay. Okay. Okay, so let's start with our calculations. Huh? We are supposed to calculate angular magnification or the magnifying power. We are supposed to calculate angular magnification or the magnifying power. Angular magnification or the magnifying power. See, what's the definition of angular magnification? It is the ratio of angle subtended by image and object on the eye when both image and object image and object are at least distance of distinct vision. Least distance of distinct vision. Distance of distinct vision. How much is least distance of distinct vision? Yes, what's the value of least distance of distinct vision? How much is it? How much is least distance of distinct vision? Yes, 25. Huh? Okay, now tell me. Which angle is subtended by image? Alpha or beta? Which angle is subtended by image? Which of the angle is subtended by image? Nah, no. Alpha is subtended by object. This is your object. This is beta which is subtended by image. So your angular magnification is the ratio of angle subtended by image and object. Beta is the angle subtended by image. Now I want to calculate this angle beta. To calculate beta, I am using this triangle A prime B prime O2. I'm using this triangle A prime B prime O2. So in triangle A prime B prime O2. Now see how much is tan beta. We can write that tan beta is almost equal to beta. And how much is tan beta? Yes, tell me, how much is tan beta in this triangle A prime, B prime, O2? Tell me the value of tan beta in this triangle. I will not start calculation until you tell me how much is tan beta in this triangle A prime, B prime, O. A prime, B prime, O2. This is over. Yes, tell me how much is tan beta. That's very wrong. So you will not even calculate tan beta. Huh? Tan beta is perpendicular upon base. How much is perpendicular? That's A prime, B prime. How much is base? It's O2 B prime. So you can write that your tan beta is it's A prime B prime divided by its O2 B prime. A prime B prime divided by O2 B prime. And what is A prime B prime? That is the height of image for the objective lens. I'm calling this as HI and I'm calling this as HO. So this is the height of image. And how much is O2 B prime? Okay, just tell me at least this term. How much is O2 to B prime? How much is the distance from O2 to B prime? Distance from O2 to B prime, that is UE. If I take sign convention, then that should be plus UE or minus UE. If I take sign convention, then that would be plus UE or minus UE, right? Minus UE, yeah. So minus of U. That's my second equation. Similarly, I want to calculate alpha. For alpha, I'm using this triangle. This is IE ABE. I'm using triangle ABE. Okay, in this triangle, can you tell me how much is tan alpha? See, I'm using small angle approximation, so tan alpha is almost equal to alpha. Can you tell me how much is alpha here in this triangle ABE? Just the ratio of sides, nothing else. How much is tan alpha? Yes, it's AB by EB. Good, it's AB by EB. How much is AB? That's object distance. How much is EB? It's minus D. See, this is minus D. Na? Here to here, it's minus D. You're moving in a direction opposite to that of light. This is the direction of light. Let's call this as equation number 3. Now I substitute 3 and 2 in 1. I'm substituting equation number 3 and 2 in 1. When I do these substitutions, what I get is beta is minus HI by UE divided by alpha, which is H naught by minus D. So your M comes out to be it's HI into D by H naught into U. That is my equation number 4. Now, if you look at these heights very carefully, what is HI? It's height of image. It's height of image for objective lens. It's height of image for objective. What is H naught? It's height of object for objective lens. That's the height of object for objective lens. So if I take the ratio of heights HI by H naught, okay, can you tell me what is HI by H naught? Height of image by height of object. What we call this term? What is HI by H naught? H naught? Ah, great. Yes, it's magnification of objective lens. Huh? If you're taking the ratio of height of image of objective, height of object of objective lens, this is M naught. What is M naught? M naught is magnification of objective lens. Magnification of objective. And this magnification we can write, you know that magnification in a lens is V by U. For a lens, magnification is V by U, image distance by object distance. So I can write this as magnification is V naught by minus U naught, right? This is I'm using that lens formula derivation. We have done in the lenses that magnification of the lens is the ratio of image distance by object distance. I'm using the same thing V naught by minus U naught. I call this as the equation number 5. And one more thing. What is H, not H, this term, D by UE? See, D is the image distance for islands. This D by UE is magnification for islands. The same expression, this is what we did in simple microscope, which you can express as 1 plus D by FE. This we have done in simple microscope. If you look at the derivation of simple microscope, you will find this calculation, how I converted UE in terms of FE. This is from simple microscope. Or you can say this is the magnification of islands. This is magnification of islands. I call this as equation number 6. Now what I can do is I can take this equation number 5. I can take my equation number 6 and can substitute both these equations in 4. Now I substitute 5. I substitute 6 in your equation number 4. When I do all these substitutions, see what I get is I get my angular magnification is ME into M naught. Right? See, this is your M naught and this is your ME. This is your M naught and this is ME. When you multiply them, it's the product of M naught and ME. And this you can write as how much is ME? ME is 1 plus D by FE. How much is M naught? It's minus of V naught by U naught. So you can write that your M is minus of V naught by U naught 1 plus D by FE. This is the angular magnification of the microscope, compound microscope, minus V naught by U naught 1 plus D by FE. And one more thing, it's not a general formula. This formula is valid only for this case. It's not even valid for another case of compound microscope. So no need to consider sign. No need to consider sign. So we don't consider sign in the relations of optical instruments. These are not general relations. These are particular relations. They are valid for one particular case only. See, next what we can do is we can see in this diagram. I'm using another color. See, this distance between the objective lens and the eye lens is represented by L. L is length of the tube. L means the length of tube. L is the length of the tube. And here the length of the tube is here to here, this V naught, then here to here, which is UE. It's mod of V naught plus mod of V. I'm just putting mod because it's not an optical distance. It's a separation. It cannot be negative. So mod of V naught plus mod of VE is your length of tube. I'm taking one approximation now. After this derivation, I'm taking one approximation. I am taking one approximation. Okay, just note it down. Then we'll start with the approximation. Okay, just tell me when you have written. Then we'll do the approximations. Okay, see the next thing. The approximation that we use here is the approximation says your object is this, your object. This object is very, very close to the focus. Object is very close to the focus. Object is very, very close to the focus. So if your object is very close to the focus, then you can say yes, your U naught is almost equal to F naught. See, if your object is very close to the focus, so your U naught will be equal to F naught. And your image, this intermediate image, this A prime, B prime is very close to I lens. In that case, you can say that V naught is equal to L. If this image is here, then your V naught is almost equal to L. And image A prime, B prime is close to I lens. If it is very, very close to I lens, then you would say that your V naught is almost equal to L. When I do these substitutions here, then I would get that angular magnification is minus L by F naught 1 plus D by Fe. But I'm saying it again, it's an approximation. Okay, this one is the exact expression, minus V naught by U naught 1 plus D by Fe. There's one more thing about compound microscope is, and that is that your final image is inverted with respect to object. Your final, that's why you are getting a negative sign here. It says that your final image is inverted with respect to object. Is inverted with respect to object. This is it. This is the final approximation. Okay, just note it down. Then we will do the second case, that if your final image is at infinity, then what happens? Just note it down. Then we'll start with the next case. Okay, you didn't get L. See, Jumena, L is just the distance between these two lenses. This is objective lens and this is the eye lens. The distance between these two lenses is known as length of tube, L. Okay. This is your image A prime, B prime. If I say that this image A prime, B prime is here, very close to the eye lens. If I'm taking this approximation, that image is very, very close to the eye lens. Then this V naught will be up to here. This image distance V naught is up to here. This would be V naught. Now, if image is here, then this is your V naught. And this is the length of the tube only. That's why I'm saying if your image is very, very close to the islands, then your V naught is approximately equal to L. Yes, Jimena, did you get it now? Did you get this thing now? Yes, length of the tube is L, which is V naught plus UE. Okay. Okay. So that was the case one. When you're obtaining your final image at least distance, there could be one more case when your final image is not at the least distance, but your final image is at infinity. Now, now it's your turn to think. This is case two when final image is at not at the least distance, but your final image is at infinity. Final image is at infinity. Yeah? Is at infinity. This is the position of your final image. Your final image is at infinity. Your final image is produced by this islands. So can you tell me when your islands will produce image at infinity? What would be the position of your object if your islands is producing image at infinity? When this lens will produce image at infinity, what should be the position of this object? Yes, you have done lens formula. When a lens produce the image at infinity, what is the position of the object corresponding to which your image is at infinity? That position of object is focus. If you place your object at the focus of the lens, then your final image is at infinity. So here I lens is producing image at infinity. That means this object A prime B prime. A prime B prime is image for objective, but it's object for the I lens. This should be at the focus of I lens. This is at the focus of I lens. Exactly at the focus of the I lens. So this UE is now equal to FE. If it is at the focus of I lens, then see here. Then after refraction, rays will not diverge. They will be parallel. The rays will become parallel. See this way. The rays are parallel now. The rays will become parallel. And when you produce them in the backward direction, they will appear to come from infinity. So that's the only difference in the ray diagram. The rest is same. Your object position will be at D only. Your final image is at infinity. Your UE is equal to FE. That is important. This is important term. UE will be equal to FE now. Okay, now tell me, is it clear? Okay, just draw this ray diagram again. Then we will start with the derivation. Just tell me when you have written it. Huh? So can I change the slide? Okay, okay. Okay. See the changes in definition. Huh? So it is the ratio of angles subtended by image and object on the eye when image is at least distance of distinct vision. Yes, it is the ratio of angles subtended by image and object on the eye when where is your image? Your image is not at least distance. When image is at infinity, when image is at infinity and object at least distance of distinct vision. And object is at least distance of distinct vision now. That's the difference. So an object at least distance of distinct vision. Your object is at least distinct vision. So m is beta by alpha, just like last. This is a prime b prime by o2 b prime. This is same. But instead of ui, what I can write is ue. Instead of ue, I can write fe. Ue is equal to fe. So instead of ue, I'm straight away substituting fe. Very, very minute changes in the derivation. Then the rest is same. The rest is same. Instead of ue, there is this fe. This minor change. So this is instead of ue, you have fe. So this is m naught. This is same. This is same. Only this is different. It's d by fe only. D by fe only. So this is just d by fe. This is just d by fe. So that's d by fe, and this is L by f naught into d by fe. So that's your angular magnification. L by minus L by f naught into d by fe. So that's the only difference between your final image at infinity and final image at least distance of distinct vision case. Just note it down and tell me when you have written. Huh? Then we will do numericals on these concepts. Just tell me when you have written. Huh? We'll do few numericals on this one. Okay. 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 Okay, let's solve some numericals on this concept. Huh? The first one is formula based. I'm expecting that you people will solve it. The next would be a bit tricky, so I will solve the next numerical, but this is straightforward. You are given two converging lenses of focal length 1.25 centimeter and 5 centimeter to design a compound microscope. To design a compound microscope. So it's very natural that this 1.25 is basically your objective and this is your eye length. The focal length of eye lens is greater than that of objective. Find angular magnification if first part. Final image is at least distance of distinct vision. Second part, final image is at infinity. Final image is at infinity. There's one more thing which is given, and that is object distance is, okay, now let's make it tricky. Yeah? Your object distance is, say it is 5 centimeter. Now solve it. Okay, you solve the second part and I will solve the first one. I think second is easier. See, first of all, using this giving object distance, and this is the focal length of objective lens, try to calculate V naught. Because even if you are solving part 2 first, the angular magnification is minus of V naught by U naught into D by FE. Say you have D, you know how much is D. D is 25 centimeter. You know how much is FE. FE is 5 centimeter. You know how much is U naught. The only issue is this V naught. To get this V naught, apply lens formula. 1 by V naught minus 1 by U naught is 1 by F naught. And get the value of V naught now. Do it, do it. Sure, okay. Juvena, any answer? No, 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 no. V2. No, 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 not at all. Okay, I'm solving this part. Okay. I'm solving part two for you. You will solve the part one. So I have D. You know that D is 25 centimeter. We have FE. FE is 5 centimeter. We have U naught, which is 5 centimeter. The only issue is V naught. To get V naught, I will be using length formula 1 by V naught minus 1 by U naught is 1 by F naught. What I can do is I can substitute all these values. U naught length, this is length formula. I have to substitute all values with proper sign. So I'm putting U naught as minus 5 centimeter. See, I'm putting F naught as 1.25 centimeter. I just need V naught. So when I do these calculations, I will get 1 by V naught is 1 by F naught plus 1 by U naught. So it comes out to be 1 by F naught means 1 by 1.25. 1 by U naught means minus 1 by 5. So this 1 by V naught comes out to be LCM is 5, right? 1.254 minus 1. So that comes out to 3 by 5. So your V naught comes out to be 5 by 3 meter. So once you have V naught, you can just substitute all values. Okay, do it now. Now put all these values here, get the value of M, and then try to solve part 1. Then solve part 1. Huh? Yes. Okay, Jumana, now solve part 1. Okay, this is correct. Now solve part 1. Part 1, huh? Part 2 you have already solved. VE. But Jumana, you don't need VE, na? For M, you don't need VE. You just need U naught, V naught, D, and FE. Although VE in this case is 25 centimeter, but you don't exactly need VE. You need D, FE, U naught, V naught. Okay, Jumena, let's see what are you doing. Huh? So M is minus of V naught by U naught 1 plus D over Fe. Let's keep on substituting the values. How much is V naught? V naught is 5 by 3 only. It's 5 by 3. How much is U naught? U naught is 5, right? 1 plus. How much is D? It's 25. How much is Fe? 5. So it gets cancelled out. It gets cancelled out. Your M comes out to be minus 1 by 3 into 6. Isn't it 2? Yeah, Jubana? Why we're getting this term, this number, this huge number? Jubana,
Uh,
why you were getting this huge number?
I gave minus 3 by 5 into
Why, why?
5.
Why 3 by 5? 1 V naught is 5 by 3 now. Okay, just write it down. We'll do one more numerical on this concept. Huh? Just tell me when you have written it. Let's do one more numerical on this concept. Solve this numerical. And I will not help in this numerical. A compound microscope use an objective lens of focal length 5 centimeter, not 5, 4 centimeter, 4 centimeter, and eye lens of focal length 10 centimeter. Object is placed at 6 centimeter from object. It's more like the last one, huh? 6 centimeter from objective. So you have U naught, you have F naught, you have Fe. Find, and don't make any mistake this time, magnifying power of compound microscope if final image is formed at near point. Second point, length of tube. Okay, solve it. And please don't make any mistake this time. This, the first part is same as that of the last numerical that I gave. Only in second case you have to think. Yes, Jubain, are you solving? Okay, good. So no, no, no. You're making mistake in V naught again. You are making mistake in calculating V naught. See, just check your calculations, huh? You took F naught equal to 4. I won't solve it. You will repeat your calculations again. I'm just giving you a hint. You took U naught equal to minus of 6.
Sorry, sir. I took 5.
Repeat these calculations again and get the value of V naught. Yes, now you are correct. Now you are correct. Now calculate magnifying power. Get the value of M now. This is correct. Now get the value of M. Yes, how much is M? How much is M? Yeah, FE is 10, but you are not supposed to calculate FE, na? You're supposed to calculate M, magnifying power. How much is it? Yes, it's 10 centimeters. It's written 10 centimeters. Okay. Wait. D is 25. D is always least distance of distinct vision, which is 25. Yes, very good. It's correct. Yes, yes. This one is correct. Huh? This is correct. Okay, this is correct. No, for the second part, I'm giving you a hint. For length of tube is V naught plus UE. See, you have already V naught. Huh? You know V naught. V naught is 12. Huh? Okay, for UE, use this relation 1 by VE minus 1 by UE is 1 by FE. You know UE. UE is object distance for eye length, which is minus 25. Oh, sorry, not UE. You know VE. VE is minus 25 centimeter. FE is given. You can calculate UE now. Once you have UE, substitute it here. And your UE should comes out to be 50 by 7. Minus 50 by 7. So the second part is your homework. The final answer of the second part is 19.14 centimeter. This is your homework. The second part is your homework. Final answer is 19.14 centimeter. Okay, so let's stop here. Only telescope is left. So in the next class, we will finish up this telescope. And then we will have one more lecture for prism. Then we will start prism. Some basic things about prism. Okay, so let's stop here. The next class, we will start with this thing. Okay, love is.